Guys, this is going to be the second part of note card 23, and this is notes for chain rule and double chain rule. So let's think about this real quick. Okay, so here I can rewrite f of x. Actually, I'm going to do it on a spare sheet of paper, just in case for room. So, all right. So here it says f of x equals the tangent of the square root of 3x. I'm going to write this a little bit easier. This is like saying tangent of 3x raised to the 1/2 power. The entire 3x is getting raised to the 1/2 power because the entire 3x is in the radical. So to find f prime, I need to apply the chain rule. So here's the outside, here's the inside. So we do the derivative of the outside, which is secant squared. We leave the inside alone, times the derivative of the inside. And the derivative of the inside is simply, well, the inside is 3x quantity to the 1/2 power. All right, so let's go ahead and keep simplifying this. Okay, so secant squared of this thing, which is just root 3x. Okay, I'm just going to leave it like that. Now, how do I take the derivative of this thing? I'd have to do the chain rule again. The 1/2 comes out front. Okay. 3x, but that gets taken to the negative 1/2 power now, because you got to subtract 1. Okay. Times the derivative of the inside function, which is now 3x. So if we want to see what we have now, if we keep simplifying at the same time, we have that times 1/2. Now I can take this 3x to the negative 1/2 power and put it down into the denominator. And the derivative of 3x is simply 3, or 3 over 1, and this is over 1. So if I want to write this a little bit nicer, along the numerators I have a 3 secant squared of root 3x, 1 times 1, don't need to put those. And in the denominators I have a 1 times 1, that's 1, times 2, and I can rewrite this as a radical. So 3x to the 1/2 power is just root 3x. So that's probably the nicest way we can write it. And what did we do there? We used chain rule multiple times. Now let's try number 2. So we have y equals -6 over the square root of cosecant of x. Now let's not take derivatives yet. Let's write this in a nicer way. So this is like saying -6 over cosecant of x raised to the 1/2 power. And then for simplifying, we could do quotient rule here if we wanted to, but let's take this thing and move it up to the top. So let's do -6 times the cosecant of x to the negative 1/2 power. Okay, so all I have done is I've rewritten what y is. So this is still y. Now it's time to take derivatives. So let's find y prime. -6 is a coefficient, it stays. This negative 1/2 comes out front. The inside function is cosecant of x, so we're going to put that in there. We're going to reduce this power by 1. But now we have to multiply times the derivative of cosecant of x. And the derivative of cosecant of x is negative cosecant of x times the cotangent of x. Okay. So let's kind of see what we have here. So I have a -6 over 1 times a -1 over 2 times a 1 over cosecant of x to the positive 3/2 power times a negative cosecant of x cotangent of x over 1. Okay. So you have a negative 6 times a negative 1, positive 6 times 1, positive 6 times a negative 1, that's negative 6. So I have negative 6 cosecant of x, cotangent of x, over 1 times 2 times 1 is 2, and I can rewrite this. Okay? I can rewrite it as square root of cosecant of x to the third power. Okay, so that's one way you could write the answer. Or if you want to think about this a little bit deeper, if you have 3 of these, you could put them all 3 underneath the radical. So cosecant of x times another cosecant of x times another cosecant of x. Well, for every 2 that you get, you can pull one of them out. Okay, every 2 underneath, you can pull one out. So if you do that, this cosecant of x cancels out that cosecant of x. So you could actually write the answer as negative 6 cotangent of x over 2 times the square root of a single cosecant of x. So that could also work. Okay. That could also be the answer. Both of these are equivalent to each other. All right, let's do number 3. We have g of x equals 4 times the cube root of tangent of x over 7. Let's rewrite it a different way. So taking a derivative will be easier. 4 times, instead of something as a cube root, you can write this as tangent of x over 7 to the 1/3 power. And you could also write the x over 7 as 1/7 times x. So when it's time to take a derivative here, the 4 is a coefficient, it stays. This is considered the inside, something raised to the 1/3. So the 1/3 comes out front. The inside stays the same. We reduce its power by 1. So if I subtract 1 from 1/3, I get negative 2/3. But then I have to multiply that times the derivative of tangent of 1/7 x. So how am I going to do that? What's the derivative of this? It's another chain rule. Tangent is now the outside function. So the derivative of tangent is secant squared with respect to what's already inside. But now you got to multiply that times the derivative of the inside function. So the derivative of 1/7 x is simply 1/7. So you have 4 over 1 times 1 over 3 times 1 over the tangent of x over 7 to the positive 2/3 power times all that over 1 times 1/7. So a nicer way to write it, just kind of go across. 4 times 1 times 1 times 1 is 4. So we get 4 secant squared of x over 7 over 7 times 1 times 3 times 1 is 21. Okay, and I can rewrite this as a radical. It's a cube root of tangent of x to the 7th squared. And you can put the squared right there. So it's a little bit nicer way to write it. Next problem. Y equals cosine cubed of 5 minus 2x. Don't forget, you can rewrite this a different way. You can say this is the same thing as cosine of 5 minus 2x all raised to the third power. Why write it like this? Because it's easier to take the derivative. So y prime equals, the 3 comes out front. Here's the whole inside, so we're going to leave that alone. We reduce the power by 1, but now I have to remember to take the derivative of the inside, and this is the entire inside. So when I take the derivative of the inside, I have another chain rule. That's the outside function. So the derivative of cosine is negative sine with respect to whatever's inside, times the actual derivative of this. So the derivative of that, derivative of 5 is 0, the derivative of negative 2x is negative 2. So if I put these two things together and multiply them, negative 1 times negative 2 is positive 2. So that's 2 sine of 5 minus 2x. And bring the rest down. Three cosine squared of 5 minus 2x. I can write it like that. Okay. All I did was just move this 2 right there. You're allowed to write cosines like that, any trig function like that. So now if we multiply, we can bring the coefficients together. If we multiply those together first, so 3 times 2 is 6. So 6 cosine squared of 5 minus 2x times the sine of 5 minus 2x. And that right there is the derivative. Nice, easy to read form. All right, let's try the next problem. Number 5. It says if y equals the function h of x quantity squared and h of 3 equals negative 2 and h prime of 3 equals 4, find y prime of 3. So before I can find y prime of 3, I need to find y prime for all of x. So I first need to find y prime of x. So this is the inside. Inside, something's getting raised to the second power. So 2 gets put out front. Inside stays the same. We reduce the power by 1 times the derivative of the inside. So if I want to find y prime evaluated at 3, everywhere I see an x, I'm going to plug in a 3. Don't really need to put the first power because that's just itself. Anything raised to the first power is itself, times h prime of 3. So 2, what is h of 3? It tells me in the problem h of 3 is negative 2 times h prime of 3 is 4. So 2 times negative 2 is negative 4 times 4 is negative 16. Number 6 says the velocity is given by this function, which I can also write v of t equals the sine of 5t raised to the 6th power. It says find the acceleration for any time t. So they want to know what the equation for a of t is. And what do I know about a of t? It's the derivative of velocity. So the 6 comes out front. The inside stays the same. The power gets reduced by 1 times the derivative of the inside. The derivative of the inside function is sine of 5t. Now to find the derivative of that, you got to do chain rule again. Derivative of sine is cosine with respect to the 5t times the derivative of 5t. So 6 sine to the 5th of 5t times all that. You can put the coefficients together. 6 times 5 is 30. So 30 sine of 5t raised to the 5th power times cosine of 5t. So that right there is the acceleration right here. All right. Number 7. Almost done, guys. It says, using the table below, find y prime of -1 if y equals h of g of x. So before I can find y prime at -1, I need to find y prime for all of x. So to find y prime for all of x, I have to use the chain rule. That's the outside, that's the inside. Remember, this is a composition, not a product. So you take the derivative of the outside and leave the inside alone, times the derivative of the inside. So to find y prime at -1, I'm going to do h prime of g of -1 times g prime of -1. So what's g of -1? G of -1 is 2. G prime of -1 is -2. Using the table again, h prime of 2 is -6. So I have -6 times -2 there, which is a positive 12. All right, number 8. It says, find the instantaneous velocity at time equals 0. So what I'm looking for is I'm looking for v of 0. It gives me the position function. And let's rewrite the position function another way. So I have 5 over 1 minus t squared. Now, if there's no index in front of it, then it's a square root. So this is actually getting raised to the 3/2 power. Now we can take this whole thing and move it up to the numerator by changing the positive power into a negative power. So 5 times 1 minus t squared to the negative 3/2 power. Now why do that? Because it's easier to take a derivative when it's written like this. Okay, so that's the position function, just rewritten. Now let's find the velocity function. We know velocity is the derivative of position. So the 5 coefficient stays. The negative 3/2 comes out front. The inside function stays the same. We reduce this by 1. Now we have to multiply it times the derivative of the inside function. So the derivative of 1 minus t squared would be negative 2t. So here, 5 times, this is like 5 over 1. So if I want to rewrite it, I got 5 over 1 times negative 3 over 2 times 1 over 1 minus t squared to the positive 5/2 power times negative 2t over 1. So here, this 2 will cancel out that 2. 5 times negative 3 is negative 15 times 1 is negative 15 times negative t is positive 15t. And here, I can rewrite this as a big square root 1 minus t squared to the 5th power. So that's the velocity function. Now to figure out what v of 0 is, everywhere I see a t, I'm going to plug in 0. So 15 times 0 over the square root of 1 minus 0 squared raised to the 5th power. So that's 0 over square root of 1 to the 5th, which is 0 over the square root of 1, which is 0 over 1, which is, of course, 0. And it says interpret the meaning of this. At time t equals 0, since the velocity equals 0, the particle is stopped. Or you could say at rest. At exactly the beginning, time equals 0, the particle is at rest. So number 9, it's asking me to find the derivative. Let's rewrite the function. 3x squared looks good. It'll be easy to take the derivative of that. But let's change the 2 over x into 2x to the negative first power. That way it'll be easier to take the derivative. So f prime, the derivative of that term, real simple, will just be 6x. Okay. For the next term, the coefficient stays. That's a chain rule. Okay. So you have to take the derivative of the outside. Derivative of cotangent is negative cosecant squared of whatever's on the inside times the derivative of the inside. So what would the derivative of that be? It would be 2 times negative 1, which is negative 2, and reduce the power by 1. So a nicer way to write it would be 6x. If you think about these numbers here, you'd have 5 times negative 1, that's negative 5, times negative 2, that's positive 10. And you can rewrite this 2x to the negative 1 as just 2 over x. And then instead of writing x negative 2, you can just put this over x squared. So you could write the answer like this, or you can choose to get a common denominator here. If you put an x squared there, you need to put another x squared there. So you could also write it as 6x cubed plus 10 cosecant squared of 2 over x. That whole thing over x squared. Now you got a common denominator. All right, last problem on this extremely long note card. All right, what I would choose to do, I would choose to move this up here. So I would say y equals negative 2x cubed times 3 minus 8x raised to the negative 4th power. Now I have a product, so I would apply the product rule to find the derivative. All right, so y prime, the derivative of the first, which would be negative 6x squared times the second, 3 minus 8x to the negative 4th. You could also use the quotient rule if you'd rather use the quotient rule. Okay, you could definitely do that. I think it's easier to use the product rule though. When you use the product rule, it's always a plus the first here times the derivative of the second. So how would you find the derivative of this? You would have to use chain rule. So the negative 4 comes out front. 3 minus 8x stays alone. Okay. You drop the power by 1, and then you multiply times the derivative of the inside, which would be negative 8. So if you're thinking about what would this actually look like, you can move this part again down to the denominator. 3 minus 8x to the 4th. You'd have negative 6x squared there. Okay. Let's think about our coefficient here. You got a negative 2, negative 4, so you're up to 8. 8 times negative 8 is negative 64. Okay. And then you can send this thing back down. So 3 minus 8x, but to the 5th power. So you could write the answer to the derivative like that. Or if you wanted to, you could multiply this first fraction by another 3 minus 8x. So that way you'll get a common denominator of 3 minus 8x to the 5th power. And then if you actually distribute that negative 6x squared, you would get negative 18x squared plus, what is that, 48x cubed minus 64. And you could also do some other factoring and things like that. Okay, you could take out, what's the biggest number you could take out? It looks like 2 is the biggest number you could take out. All right. So you could do that as well. Or you could use the quotient rule. If you use the quotient rule, you probably get this answer. Okay. I'm going to do that problem now, but I'm going to do it as a quotient rule just to show you should get the same answer. Okay. So same problem, but I'm going to use the quotient rule this time. So if that's my original problem, if you didn't want to use product rule, you'd have to use quotient rule. Okay. So low (3 minus 8x to the fourth). D high, derivative of high would be negative 6x squared minus high D low, so derivative of low, you'd have to use the chain rule, 3 minus 8x to the third times negative 8 all over low squared. Okay. So here, let's just do a little bit. So I'm just going to write this as negative 6x squared times 3 minus 8x to the fourth. Okay. Minus, actually, you got two negatives next to each other. Let's just treat these as two positives. So we'll write plus. All right, 2 times 4 is 8, times negative 8 is negative 64. Okay, negative 64x cubed. Okay, so I took care of the 2, the x cubed, the 4, and that negative 8. And then we still have 3 minus 8x cubed on the bottom. Power to a power, you multiply them. 3 minus 8x, that would get to the 8th power. So what can you do? The answers don't look like each other anymore. You could factor out a 3 minus 8x cubed from both. So if I factor out a 3 minus 8x, the lowest power that they both have is 3. So what do I still have left? I took out 3 of these things. I still have one of them left, 3 minus 8x, and I also have a negative 6x squared. Okay. I took all 3 of these out, so I still have a negative 64x cubed there. On the bottom, I have 3 minus 8x to the 8th. Well, 3 of these knock out 3 of these, so there's only 5 left on the bottom. And if you distribute, okay, 3 times negative 6x squared is negative 18x squared. Negative 8x times negative 6x squared is positive 48x cubed. Then we have a minus 64 64x cubed. Sorry, on my problem, I forgot this x cubed from there. Okay. All over 3 minus 8x to the 5th. Okay. So if you notice here, negative 18x squared plus 48x cubed minus 64x cubed, and that's pretty much the same thing I got here. Negative 18x squared plus 48x cubed minus 64x cubed, all over 3 minus 8x to the 5th. And actually, I could have made this a little bit better. I should have simplified those, because they're both x cubes. So negative 18x squared, this minus this would be negative 16x cubed over 3 minus 8x to the 5th. That's a better way to write it. Or you could even go further than that. You could take out a negative 2x squared there, and you would get 9 minus 8x. So those are even better. Same answer either way. Whether product rule or quotient rule, you're more likely to make a mistake. That's why I would rather you just take this, move it up to the numerator by making it into a negative exponent. Product rule is easy. Okay, you don't have to remember any sayings. It's just derivative of first times second plus first times derivative of second. That's all you got to do. So it's a really long note card. Sorry I had to split it up over 2 videos. I just wanted you guys to have lots of examples to reference back if you need them. Thank you for watching.